Oh yeah, so just going to run through the how to install and compile the NVIDIA Instant Neural Graphics primitives, because I've had a few people comment and say they've got a bit stuck, so hopefully this will help. I'm not going to go through the whole installation process, but I'm just going to go into a bit more detail than I did on the last one. So you need an NVIDIA GPU. I would get something like a 1080 or higher, ideally, although some people have had them running on a 970. It'll be very, very slow. The more CUDA cores you've got, the faster it will be. You need to have a C++ compiler. Install Windows Visual Studio 2019. I'm not going to run through that because that's very straightforward. Just Google it, download it, install it. When you do that, if you search Windows for, in your Windows search for developer, you'll see developer console, developer command prompt pop up. And then if you open that up, you'll get the developer console, which is what's required. You have to use this console to do the compiling and to do. I don't think you need to use it for the video to images script, but I've been using this thing the whole time. So anyway, so install that, and then once you've installed Windows Visual Studio 2019, you'll get access to this. Install Cuda, so just click on this link, follow the instructions, install it. Yeah, so install Cuda 10.2 or higher. That's pretty straightforward. I didn't have any problems with that. CMAKE, again, click and install. Click to open this and to install it. Click the download button over here. I used 3.22.3, so find 3.22.3. 3.22.3. Okay, well, I mean, I got it working with 3.22.3, so try 3.22.4. I definitely had problems with 3.23 with this one. So try 3.22.4. Hopefully that will work for you. If not, let me know. I'd be curious to know if that's a problem for anyone. Python, you can install by just going to the Windows Store and installing Python 3.7 or higher. You can also just install it manually yourself if you want to. Okay, I'll go back to this pip install requirements. Optix again, just click on this and install 7.3 or higher. That should be straightforward as well. So, okay, right. The other thing that you need to do is you need to install git clone. You need to install git and do a git clone. Alternatively, you could probably just download the code here, download the zip and extract it, and then you'll have this folder structure in a zip file. So unzip it somewhere on your hard drive, somewhere without spaces in the file path, go into it and you should see all the files there. This one's been compiled already, so it might be a few extra folders here that you don't have, but yeah, this is what you should have, something like this. So then the next thing you need to do is do pip install our requirements. So this is a Python install command, and in your folder you've got a requirements.txt. If you open that up, these are all the things that this system uses. OpenCV Python and lots of other utilities. Lots of cool, interesting stuff here. So to make sure you've got everything that you need to open up your developer console. Okay, if you type in Python, you'll get a Python command prompt with these three arrows pointing this way. So if you do type in Python and you can see that, you've got Python installed correctly, because Python is required to be on the path, on the system path, so that when you type in commands like Python, no matter which folder you're in, the developer console can access the Python library to run commands and code. So the other thing that you need to have is Colmap. So if you do Colmap-H, you'll see a bunch of the Colmap helper arguments that you can use, or if you dive into it a bit more deeper, in a bit more detail. So if you type in Colmap, again, that should show this list of commands here. Very important that that shows up. If it doesn't, you need to go into the environment variables, which I'll get into in a sec. The last thing, no, two more things. So CMAKE, if you type CMAKE-H, again, you'll get a bunch of commands. If you don't get this back, if you get an error, then CMAKE is not installed correctly. Again, you need to check the environment variables. CMAKE needs to be available in the system path. And the last one is ffmpeg. This is a very, very cool utility. It's used for transcoding video. You can use it to do all kinds of things. I've been using it for years and years and years. You can use it to convert MKV to MP4. You can use it to convert MP4 to a list of sequential images, which is what this tool is using it for. You can convert audio. You can change bitrate compression. You can reduce file sizes. There's so many different things. You can stream video. You can use it with your webcam. There's all kinds of things you can do. It's a really one of my favorite libraries, actually. I think it's if you don't know ffmpeg, go and check it out. This one, check out the documentation. It's check it out. It's really cool. So that's that. If you want to just use a command to download the thing, you can install Git. Just have a look on YouTube about how to install Git and how to use it. It's just another tool. It's also very useful for developers. Yeah. So if you've got CMAKE installed, you'll get your commands pop up there. So that'll be the next thing to do. But before we do that, if you just do a search for environment, you'll see edit the system environment variables. If you open that up and click on this environment variables button over here, these are the file paths that point towards things like Python, like Colmap, like CMAKE, and you need to have these in as system environment variables. All they do is just point the code, point the console to the right code directory. So Cuda path, for example, this will be one that's important to have. This should all be, most of these should be installed automatically. Cuda _visible devices set to 0 is something I needed because I've got 2 GPUs, and NVIDIA _visible devices I set to 0 because I've got 2 GPUs. If you've only got 1 GPU, you probably don't need to add these 2 environment variables. The path here, there's nothing else here. So the next thing to look at is the path. Okay, so if you go in here and click edit, these are this is the way that the system points around to the different file systems, to the different libraries and code bases. So I've got C. I installed mine ffmpeg to C ffmpeg, and you need to have \bin in there. So when I type in ffmpeg, I might go over this more often than I should probably. This pops up. If I remove typing in ffmpeg in the developer console will do absolutely nothing. So it's essential. You also need to have this Cuda. Again, the Cuda bin needs to be installed, and the Cuda lib library needs to be installed. Open SSH, NVIDIA, Git. That will automatically be installed if you install Git. CMAKE. So C program files, CMAKE bin. That's what I've got mine set to. I think this is automatically installed, but if not, go and check it out. And lastly, you'll need VS Code as well, probably. That's probably what you probably need that installed as well, but that'll be automatic. The one that I definitely added in manually was the Colmap library, which I installed a C Colmap, etc., 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 and I added in the bin and the lib folders. So all you to do this yourself, just click new and just paste the location of the lib or the bin directory. Simple. So once you've done that, you would go into your developer console and navigate over to this directory here by copying the path, and then go cd space paste and navigate to wherever these folders are installed for you. Then you can start compiling things. So the first command is this one here. Ignore this. This is just the user in Linux. So just copy that, copy, paste, and run it. I'm not going to do it because I've done mine already, and it takes quite a while. Even on my 24-core Threadripper, it takes a good 5-10 minutes. So run that. You shouldn't have any problems. If, as I said before, you can run ffmpeg, you can run Colmap -h, you can run CMAKE, or if you can run all those commands, CMAKE -h, ffmpeg -h, you can run all those commands and you get some sort of response back. You should not have any problems here. If you do, just drop me a comment, and if I can help, I'll try and give you a hand if there's anything that you're stuck on, or do a video and upload it to YouTube and show me. Oh yeah, I definitely found this list of possible fixes helpful. Just search in here for your error code. The documentation in this is amazing. I had a bunch of errors, mainly because I just didn't read the documentation and just tried to install it myself. Always read the docs. Anyway, so you build you build it with these two commands. That's it. Once it's been built, you should. Here we go. You should be able to go in and run an example. This is what comes with the system. So I'm in ls. If I do a directory, if you type in dir on Windows, you get a list of all the files that are in the folder that you're in at the time. So I'm in my root directory, which is this one here, which is where I need to be to run this command. So if I want to build the Fox, I'm here basically saying, let me get this up in here. I'm saying, you also need to put quotes around the first command, because Windows gets a bit confused with the ./. So double quotes, and then ./build/testbed, and then --scene, which is data NERF Fox, which is, if I go back to the folder, which is data NERF Fox. So, and then what it does is it knows that there's an images folder in here, and it's able to build it from here. So if I just run that from empty data, there's no transforms image in here. Why is there no transforms image? Yeah, there should be a transform image in there. Let me see if it's in here. Data, NERF Fox, transforms, yeah. Let me just go in here. I'll just copy the file. I must have deleted it. Hang on, let me just skip forward a bit. Okay, so let's go into the Fox, and you need to have this will be in your file, transforms.json. But I'm just going to add it in manually here. Paste. So you can see that it's pointing to images / and then a numbered JPEG, which is obviously corresponding to this images folder over here, which contains all the images. If I just save that, let's go back to our command prompt. Cannot load NERF data from an empty set of paths because there's no transforms. Okay, so let's try running that command again. There we go. So that's it. And that's running. You might have some trouble stopping the training. I find that you have to hit the button just at the right time as you hit the stop button, just as it highlights. Often it just doesn't stop training. I imagine on older cars it's even more difficult sometimes. So just one of the pain points with this, but it's awesome. It's amazing, but yeah, hopefully it's going to get a bit more work. Fingers crossed. Okay, let's go back here. Okay, so that's the command. No, that's not the command. This is the command to build if you have a data set already built for you. So put a quote around there, put a quote around there. Okay, so if you've got all your data already, that's what you do. Okay, so now let's do one from scratch. Okay, so the next thing to do is make sure that you've got Colmap installed. So for more information about preparing your own data sets to use with NERF implementation, please see this document. So before we can use our own video to create our own data sets like this Fox example, we've got to install Colmap. So if you go over to that link, read through this whole thing here. It's quite interesting. Explains the transforms file. But you need to go to Colmap over here and installation. Oh, it's this one here. Demuc.de Colmap, and then go to. Can't remember if I went for the pre-release version. I got Colmap 3.7. Yeah, that's this one. Okay, yeah. So scroll down here and install Colmap 3-3.7 Windows Cuda.zip. Okay, so just download that, install that to wherever you want. I've installed that to my C drive. C drive Colmap, and then remember I've added in the lib and the bin folders in the path, and the system path and environment variables. And that's it. That is it. That is done. Once you've done that, if I come back to, so this talks you through about what Colmap is doing. Here we go. Here we go. Here we go. Okay. Colmap NERF. Right. There's the code. There's the line. So, okay, let's explain this. Now, the first one, this is what builds based on an existing training set, and this one formats the video and does the training set in one fell swoop. So if you've already got a list of images that are sequentially named correctly, you don't need to do some parts of this argument. Here you can take out this one, for example. But if you've got a video, and I've found that video for some reason, for whatever reason, works better than sequential images that you've taken yourself using a camera. For example, like if you're doing photogrammetry, that's the sort of thing you would do to get better quality images. But for whatever reason, this library, these neural graphics primitives just work better with video. I guess it's something to do with the fact that the camera data is much more is able to be produced in a much more reliable and more accurate method, because the video is obviously quite smooth as you're moving around the model. I guess it's something to do with that, because I've not been able to get sequential images that I've taken myself individually to produce anything particularly good. The videos always tend to work really well. So So what you have to do is you have to run Python, and you have to give it a path, which is going to be inside the scripts, and then Colmap to NERF. That's the script. So if I go back to the folder, I go into the top level again, I go into scripts. In here, there is a Colmap to NERF .py script. If we open that up, you can read through it and see exactly what it's doing, and you can see all the dependencies that it has, some of which these needed to be installed with the requirements.txt file. If you're a dev, obviously you can have a read through this and you'll understand what's going on, to some extent at least. These are the arguments. Video FPS is how fast, it's how many frames you take per second. So if I do video in and I do, we'll use, I've got an example here, which if I go to ngp data, NERF, bear. I've got a bear.mp4 here, which is this video file. Just a video file, just me walking around, videoing this bear, and all the script will do is it'll take a couple of frames every second and put it into an images folder. So let's just pretend I haven't done anything here, delete those, copy the bear, go back up to scripts, paste the bear in here. You can obviously modify the script to find where the video is yourself if you want to, but I'm just going to do it like this so that it's next to the script. So we want to run this code here, and we want it to grab bear.mp4, video in bear.mp4. So that's the argument, bear.mp4, which is bear.mp4, and the location of the file is important, obviously. How many frames do we want to pull out of this video every 2 seconds? This is what ffmpeg is being used for. And then we want to run Colmap on the images folder. So this one here. Run Colmap on the image folder. So what will happen is this will get created. In fact, let's just run it. So I'm in my developer command prompt. My current directory, present working directory. Yeah, so I need to go into the scripts folder. So I do cd scripts, and if I dir, I can see, oh, there's my bear, and there's the Colmap to NERF. So I'm in the right directory in terms of this console. So if I run this command, I'm going to say Python, run this Colmap to NERF.py, and it accepts an argument, which is video in, which is bear.mp4. Give me 2 frames out of every second out of that video, and then run Colmap on the images folder. So if I go back in here, let's see, we're in scripts. We should see an images folder pop up over here, and we should see a transforms. I can delete that one. We should see a transforms being created here. And the Colmap text and sparse you might not have in your folder. These get created with the script as well. So let's run it. Python count find file, no such file or directory. cd. Okay. That's because I've got Python /scripts. I'm already in the right directory. I don't need to type /scripts. If I was in the directory, if I was here, I could put /scripts and it would find it. But anyway, let's try it again. Warning, the images folder will be deleted. Well, there is no images folder in there. That's okay. Thanks for the warning. Press yes. Oh, look, there's the images folder popped in. And there's all the images. Look how quick ffmpeg is at creating sequential images for you. Amazing. So now the developer command prompt is waiting for me to say yes to, do you want to delete the Colmap sparse and the Colmap text folders? Oh, yes. Let's delete them ourselves. Yes, I do. They're going to be overwritten, and then our transform file will be created. So yes, I do want to overwrite, and I do want the Colmap images and folders to be created here. Not images, the Colmap folders. And most importantly, the transforms.json. Hey, success. So we've got our transforms JSON, and let's use these folders, which we don't really need. This is what it uses to do the training of the images. But what we do need is we need the transforms.json, and we do need the images. So what I've been doing is grabbing these three and Control X to cut them, and then go into instant NGP, go into data, NERF, create a folder in here for your tests, and then paste everything in there. So that you'll have a transforms, you'll have your original video as I just find this is the most organized way of doing it for me personally. You can put yours wherever you want. You might need it to be in data, NERF possibly, I'm not sure, I haven't tried. Try it if you want. I haven't. So one thing I forgot to mention is that when you create these images, and these images get done in here, the script waits for you to start doing the training. So that at this point is a good time to delete the images that you don't want. So before you run the training, so look at this one. This one's a bit blurry. Actually, they're all a bit blurry. See, that one's not too bad. That one's a bit blurry. That one's not too bad. So it's a good idea to just go in and delete any really horrible blurry images. This is good practice for anything to do with photogrammetry. I haven't done that. This is just I'm just trying to get this done as quickly as possible. So, but yeah, if you want better results, delete them. Delete the images there at that point, and then hit yes to continue for the Colmap to start building the transforms file. So, last thing you need to do, open up the transforms.json and your favorite editor of choice, and make sure that you've got images, make sure this location is set correctly. So you want the transforms to be looking in the images folder. I can't remember if I needed to delete, well, we'll find out in a sec. Also make sure that you don't get any NaN values in here, not a number values. If you see NaN in the transforms, the video hasn't been processed correctly. Now we're back to square one with a Fox example. We've got instant NGP data NERF bear this time instead of Fox. So if we go over here, copy this, go back to our developer console. Now we're in the scripts folder. So if I do cd space dash dash dot dot, that'll take me up a level, which is where I need to be. And then if I do build testbed scene data NERF bear, we should get the bear simulating, and it looks good. So that's how you take the video, convert it to images, and then create a 3D representation of the bear. You can export the model, the 3D object, but there's no textures applied. So if you want to use this for practical work, for VFX or for games, you're still better off sticking with photogrammetry, with something like capturing reality or Meshroom. Yeah, that's it. I don't think I'm going to do any more NERF videos, because I don't think there's much more else I can figure out with it. I've tried using masks and it hasn't produced much better results. So I'm gonna probably, next few videos are probably going to be related to Blender or Unreal Engine if anyone's interested in that sort of stuff. So yeah, it's been fun. Go check it out. It's fun to map your family with it. Good for memories. But it's just a bit of a fun toy at the moment, I think, unless you're a developer seriously researching it. Cheers.